Okay, now we're going to look at the tan compound angle formula. Okay, so I want to recall one of our trig identities. That is that tan of theta equals sine theta over cos theta. Okay, so we need that. Also, we're going to need for later that tan is an odd function. If you look at the graph of tan, okay, so it looks like this, okay, asymptotes there and there, and another piece like this, another asymptote. If we reflect this in the y-axis and then reflect it in the x-axis, it's going to look the same. Or if we rotate it 180 degrees, it looks the exact same. Okay, so another piece there. Every 180 degrees, you have one of those pieces. Okay, so we know that tan of negative theta equals negative tan theta because it's an odd function. Okay, now tan of a plus b, we're going to use this identity here. That's going to equal sine of a plus b over cosine of a plus b. Okay. Now we're going to fill in the formulas for this. So sine of a plus b equals sine a cos b plus cos a sine b. Okay. And cos of a plus b equals cos a cos b minus sine a sine b. Okay, and then we're going to do this magical do nothing rule, where we're going to put in a fraction here that equals 1. So we multiply the top and bottom by the same thing. And to come up with this on your own would be very, very hard, but mathematicians took some time to get this. And so hopefully you can just understand the procedure here. So we're going to multiply the top by 1 over cos A cos B. Okay. And we're going to do the same to the bottom. 1 over cos A cos B. Okay. So we're really not changing the value of this because we're multiplying by something over itself. And that's just going to equal 1. Okay. Now, hopefully you can see that this cos A cos B is a piece right here. So this part here, when I multiply it by 1 over that, is going to be 1. And this part here, we're going to be able to use this identity, or tan theta equals sine over cos. So we want to get this tan of a plus b. Instead of having sines and coses in here, it'd be nice to have it in terms of just tan. Okay, I know sine and cos have it in terms of sine and cos, but if we can get the tan compound angle formula in just terms of tan, that would be very convenient. Okay, so we're going to have here multiplying this by this piece. Okay, so it's by the whole thing here. So we're going to have sine of A cos B over cos A cos B plus cos A sine B all over cos A cos B, okay, all over. So that equal sign shouldn't have been there, it should have been down here. Okay. Now we're going to do the same at the bottom here. So maybe you want to pause this video now and see if you can finish this off and see what it's going to look like, and then play it and see if you got what I got. Okay, so you know the bottom is going to be cos A cos B over cos A cos B, okay, because that's what I'm multiplying by over here, minus sine A sine B over cos A cos B. Okay, now this part here is going to equal 1. These cos B's are going to cancel out. These cos A's are going to magically cancel out. And now I'm going to have sine A over cos A. And if we look at our identity up here, sine A over cos A is going to equal tan A. And same thing here. Sine B over cos B, that's going to equal tan B. Okay, so tan B, tan A. And here, that's going to equal tan A, and this will equal tan B. Okay, so very convenient, very slick. All right, so we got tan of A plus tan of B all over 1 minus tan A tan B. Okay. So that's our compound angle formula for tan of A plus B. Okay. Now what about tan of A minus B? Well, using this identity up here, so the fact that it's an odd function, tan of minus negative theta equals negative tan of theta. Okay, so if I put in negative B into these places here, that's just going to turn that into negative tan B. For both these cases, it's just going to switch these signs. So you're going to end up with tan of A minus tan B over 1 plus tan A tan B. Okay? And that will be our other compound angle formula for tan. Okay? So let's do an example here. Jump right into an example of the radians. Okay? So how about tan of pi over 12? Well, pi over 12, if we use our table that we did before for the radian examples, well, pi over 12 is going to equal 3 pi over 12 minus 2 pi over 12. These are both special angles. Can't be just any random angle. And that's going to be tan of pi over 4 minus pi over 6. Okay. Now we can sub it into this second formula here because this is for subtraction. Okay. So it's going to be tan pi over 4 minus tan pi over 6 all over 1 plus tan pi over 4 tan pi over 6 and from our special triangles, okay, we're going to have tan pi over 4 is just it's just 1, okay, and tan pi over 6 Well, let's take a look at that. Okay. So if this is going to be pi over 6 here, then that would be pi over 3. It's 1, 2, root 3. Okay, so tan of pi over 6, tan is going to be 1 over root 3. Sorry, that's not a plus, it's a minus. 1 over root 3. Okay. And then at the bottom, it's going to be 1 plus tan pi over 4, which is 1, times tan pi over 6, which is 1 over root 3. Okay. Now, we can get a common denominator on the top. Okay, so it's going to be root 3 over root 3. So we then have root 3 minus 1 all over root 3 over, and this one would be root 3 plus 1 all over root 3. Okay. Now, when we divide fractions, we flip and multiply. Okay, so if we flip this bottom one up here, the root 3's are going to cancel out. So you can try that. You're just going to end up with that. And then you're going to have root 3 minus 1 all over root 3 plus 1. Okay? And so that would be the exact value of tan of pi over 12. Now, if you wanted to rationalize the denominator, you'd multiply the top and the bottom by root 3 minus 1 and simplify that. Okay, that's our compound angle formula for tans.